So transmission of mechanical power using gears, bearings, which the video didn't talk much about. I think we have another video on bearings. Roller chains and then belts for most people that call it. So types of gears, terminology, nomenclature, force of transmission, and of course it says design of the gearbox, but we're not going to get into that. This is some examples of, I don't forgot where I got this at, but it's a pretty neat slide. Where it shows us torque versus speed. What is torque? What is torque? Well, this is a force. It's going to cause something to turn, or it's going to tend to cause it to turn, right? Y'all understand that? So anytime I do a twisting or a turning motion, we develop what we call torque. Of course, a lot over here, we use a lot of things called horsepower. So horsepower is equal to torque times R divided by 5,000. So torque is equal to times horsepower divided by R. So power is the rate of doing work, right? Y'all understand that? So this is a nice little chart that gives you the relationship between torque, speed. So notice across the top we have 5 different powers. And then so 1 horsepower, which is about 1.5 kilowatts. So it's actually 470, I think it's 475.7 watts per horsepower. Of course, over here we use 746 is what we use. It's actually 745.5. Why you need to know that is because motors over here are sold by horsepower. In the rest of the world, they're sold by kilowatts. So if it's 746 watts per horsepower, then it's going to be 0.746 kilowatts per horsepower, right? Y'all understand that? It makes sense. So yeah, if you get one of these motors that from bought from overseas, it's not going to be rated in horsepower. It's going to be rated in what? Kilowatts. Horsepower is a strange thing. Watts make more sense. 746 watts per horsepower. Basically, horsepower was developed. I forgot who it was, guys. I should know that. But when they came out with the steam engine, these people that want to buy these things, all they knew was what? Horses. They moved everything with horses. And when I sold that, they wanted some way to be able to do what? To be able to sell it to relate to what they did with horsepower. So basically, that's what they did. They got horses and they hooked them up, and then they put a big weight down inside a well, and they would pull those things and see how fast it would cause. They could raise that weight over a certain amount of distance, and then they averaged it out. This evolved a little bit over the years, but somewhere you can look up horsepower, and that's what they're going to talk about, how much work a horse can do rated to what the steam engine could do. And then once they had that, then steam engines started selling a lot because you don't have to feed steam engines, right? They don't crap all over the place, right? All you gotta do is just have a fire, right? Where you can. So you can see the amount of torque, which is you can get over here, we rate torque in foot-pounds. The rest of the world does use pounds. So we do each pound or foot-pound. But this is just a chart that gives you. Now notice for the same horsepower, the actual work it does varies with what? What's across the top? RPM. Yeah, they vary with what? I'm sorry. T. Where's T?
It just says RPM. Motor velocity. Power.
Where's that? Oh, yeah, power's down here, but motor velocity is across the top. They said, okay, 3450, that's revolutions per minute. Then a 1 horsepower motor would generate 1.5 foot-pounds of torque. We take that same motor and get it down to 500 RPM. What happens to the foot-pounds? It goes up to 15.8. Because why? Because the motor's running at a slower speed, right? You understand? So saying a 1 horsepower motor would generate the same torque as a 1 horsepower motor, all depends on the speed that 1 horsepower motor runs at, right? You understand? So a 1750 horsepower motor would generate more torque than a 3450 horsepower motor, 1 horsepower motor. So that's the problem with horsepower and torque, is that torque is that twisted motion that causes things to move, and it varies with what? Varies with speed. So horsepower varies with speed. Torque varies with what? Speed. This is another thing I wanted to make sure you understand. Radial and actual load. The guy on video was talking about radial and actual thrust, which is thrust is something that causes something to move, right? So y'all understand radial loads and actual loads. So radial loads are loads that basically act on the radius of the circle. Actual loads are one that acts parallel to the actual shaft itself. Yeah, one of them is pressing basically, and the other one is pushing or pulling. So anytime we have these gears, and anytime we have bearings and stuff like that, we're very concerned with radial loads and actual loads, right? So if we got a heavy actual load, then we wouldn't use the same bearing that we would use for something that had a heavy radial load. So that was the gear video we looked at. Spur gear, helical gear, bevel gears, and one. Yeah, so these are spur gears. Spur gears are just gears that are machined straight across. So what's nice about spur gears, they're very easy to make, they're very easy to machine. You already see these things. I mean, they just whip them out right after the other because they're not concerned with a curve or anything, right? You understand that? So very easy to make. I've seen people make these out of plywood just by setting up a jig and making it out of a miter, not a miter, a router. Are you okay on spur gears? Parallel shafts. We okay? The guy used pinion and gear a lot. I like to use the term driver and driven, which is the guy in the second video. Because, yeah, the first video. So these are helical gears. So they get a different name, right? And what's the advantage of a helical gear? More contact, which means they'll handle more load. And also, what's another advantage of these? They're quieter, right? They run quieter. Yeah. So they run smoother. They run smoother at high speeds. Biggest advantage is they're more expensive to make, right? You got to get that slam in there. This is so if we take two helical gears and put them on opposite on the same shaft, we refer to this as a double gear, right? That makes sense. If we actually machine it, and you can see these things are going to be very complicated to machine. This is called a herringbone. Y'all understand the difference? Yes, no. Are you okay? Are you okay? Yes, no. Yeah, the other one's 2 gears. The herringbone is 1 gear, right? And what they do is they just put these on a double helical, they just put them on opposite directions. That means this one's trying to force it this way, this one's trying to force it the other way. Cancel each other out, right? Don't have, reduces the radial thrust. I'm sorry, the actual thrust. Here's our bevel gears. These are nice in that they have the same name. We have the straight bevel, which is the adamant grip on top, and then we have the spiral them, right? Are you okay? On these?
That's like the same thing on our platform.
No, that is a worm gear. No. It might be spiral, I don't remember, but it's a worm gear. So if you look at the shaft of the stepping motor, it's got the worm on it, and then the thing that spins around there, and it's throated too, if I think right. The gear is throated. So if it's throated, that means the worm can get in there. The teeth make more contact. You got more teeth in contact. So this is a worm gear. Now, of course, the advantage of worm gear is you get an extremely high gear ratio. So I've seen these things. There was one video we had where these guys would actually open up locks on a canal. The guy would pull his boat up there and get off of it and actually crank that worm gear. You see these things work jacks. They work jacks. The jacks that we use to jack up our airplanes, basically. Them were big old airplanes. That was fun, jacking it up. Basically, the modulus of the gear. So there's the gear. There's one gear though that none of these videos talk about, and but this is on the manufacturing line. It's called a ball and screw gear. Okay, no, and I couldn't find an animation of that, guys. I looked all over the place. What's the advantage of a ball and screw gear? Well, it takes a rotary motion and turn it into what? A linear motion, which is basically what we call it a rack and pinion does, but a rack and pinion takes up a lot of space. You got the pinion gear, which is the little gear, and then you got the pinion. Y'all know what I'm talking about? Thomas knows what I'm talking about. We'll look it up though. Yeah. He's my hero. He's my hero. Rack and pinion. So basically a rack and pinion. And these are rack and pinion. So we call these rack and pinion gears. So you see, what we do is we take a rotary motion and convert it into a linear motion. This is what our cars use for gear, steer, chalk, rack and pinion. You could actually see it, had a big thing down at the end. You could see where the stern wheel came down, had a big tube about real long, which was the rack. So we call this guy right here the pinion, and this guy's called the what? Rack. So it takes a rotary motion and converts it into a linear motion. Well, what does a ball and screw do? Exactly the same thing. Well, what advantage does it have? Occupies a lot less space, right? Y'all see that? So what we do is pretty neat. The way it works, can y'all see the way it works? Got a lot of balls in there, that's what it does. And when the screw turns, these bearings do just follow the groove in the screw, and then they just constantly rotate. So you see it comes out this side and just runs back around and falls right back down into the screw. So these things are the balls are constantly rotating through the actual unit. So what the linear motion that I would attach it to this. I don't even know what it's called. I guess you'd call it. And then whatever we want to turn the motion or this developing the rotary motion, we would connect that to the screw. Right? Okay, guys. Okay, guys. What will be the ratio from here to the output? B is the number of T. So we got a 15 T to 45. We got a 12 T to 48. So multiply it by 6. So it's Well, it depends on whether you're talking about speed or whether you're talking about torque. Torque, it would be 3 to 1, right?
Yeah, 15 to 45. One.
Of 1, everybody agree with that? Or 1/12. So if you're running at 1/12 the speed, but we produce 12 times the torque, right? Y'all understand that, yes or no? So it all depends on how the question is worded. So if I've got a big feeding, if I got a little feeding a big, which is what we got here, so I got a little feeding a big, so what is it multiplied 4, so divide speed. You understand that? And then over here on the same shaft, I got a little feeding a big, so this is going to take, I'll run at a slower speed, but at a higher torque. And why do we do this? Well, when we start doing these gears, a lot of times this is very, very, very similar. So instead of having this gear turn this gear, we actually put gears on the same shaft, right? And what the purpose of that is that the gear train or the gearbox will occupy less space. So we get a real good ratio between multiple gears instead of having one little tiny gear over here that's got 1 tooth for every 12 on my output, right? Does that make sense? So we see a lot of gear trains or gearboxes. Any questions on that? 1/12 or 12 to 1? Are we okay? Yes or no? Bearings. Why do we need bearings? That was somebody posted on YouTube where the dad got a big bright idea and he took his son out there and got his fidget and got his hair compressor and turned it on and was using the air compressor to spin the fidget. I know what a fidget is, right? A fidget is the thing now. So a fidget is just something for people who are fidgety. This is a fidget.
Wow. Really popular right now.
Oh, very, very popular. And guess what happened to the fidget? He got the dang thing going so fast that the fidget did what? Slung apart. Hit the boy in the, and that's what he took a picture of it. They was on the way to the hospital to get stitches, and he was talking about how stupid he was to do that. Things, if you spin anything fast enough, it's going to do what? Yeah, they don't understand the amount of centrifugal force that's on the output. Unfortunately, we don't have those mechanical merry-go-rounds that we used to do when we was kids.
I know it's probably a bad idea.
It was a bad idea, but he said it was stupid. So he calls himself stupid. So what we do with bearings, of course, is we take something that's rotating, right? You understand that, and we mount it to a fixed surface. That's what the bearing does. And how did you get the name? Because it has the bear weight. A device that is used to enable a rotational or linear movement while reducing mechanical friction of thread. Of course, most of them resemble wheels. Main function is to reduce friction and facilitate smooth rotation of an axle. So we have plain bearings, and some people call them sleeve bearings, ball bearings, and roll bearings. And then we'll call it plate. And what does it tell me to do? Yeah, so let's pause. So this is plain. So these are plain bearings. You'll run into these a lot. And so there's all it is two surfaces going together, but what you see, they're slot hot in the middle of one of them. They're made out of Teflon, they're made out of metal, with slots on them. Notice it has what? Grease fitting. These are used a lot inside your HVAC system. So if you ever look where you see a little grease hole, what you need to do probably once a year is drop a little oil down, not grease. Those are for oil, bearing oil, because these are literally rubbing two surfaces rubbing together. So the only friction they get, the only lubricant they get, or to reduce friction, is the oil that you put in there. So these are called plain bearings, sliding surface bearings. Those are the same thing. Are we okay? Then ball bearings. Okay, we're okay. Okay on the name. So we call this the outer ring. Call this the what? Inner ring. A lot of people call them the inner and outer race. What's this little plastic thing? That's the retainer. So what does the retainer do? It keeps those things equally spaced so they carry the load. And so outer ring or outer race, then we have what we call the cage or the retainer, and then we have the steel balls, and then we have the inner race. Okay, we'll go there, a retainer. Roller bearings carry load by placing on a rolling element. These are able to carry a heavier radial load. Are we okay there? Any question there? Basically the parts are the same. You can see the difference. Instead of having a ball, we have what? Rollers. It's pretty obvious the advantage of those. Thrust bearings. So I went out and got these kind of like one for one the thrust bearings are basically there to handle a heavy actual load, right? So we okay there. Your questions on bearings. I guess they got the name because they bear the load. You know, you're running the bearings all the time. The roller chains. Most people call these chains. Are we okay there? So what's the advantage of chains over gears?
You don't have to have spacing.
Yeah, spacing is not critical as long as you maintain alignment, as long as you maintain tension. All right, you understand? So the longer you go, the more it's going to fly. But you put tensioners out there on there to keep those things under tension. Any more advantage? Create change. What's that?
Great change.
Yeah, so any length, that's what we just talked about. You're looking at, you're reading those, right?
You're cheating.
Plus your input and your output move in the same direction, right? So we don't have to have an idler in there, so they're moving in the same direction. But we don't call them gears, we call the things that transmit the power now through the chain, we call them sprockets, right? Ooh, I don't know if this one's on there, guys. There's V-belts, years. I don't even think it's up on Blackboard. Let's look and see. So where's Blackboard? So the driver and the driven always turn in the same direction, right? You understand that? Another thing is that the spacing between the driver and the driven could be greater, further apart, right? You understand that? It's a really good transfer technique. The chains themselves are made out of steel. Most of them have rollers, so it's called rollers.
Yes.
What problems do you have? Yeah, they're harder to take clean. You got to keep them lubricated. If you ever rode a motorcycle with a chain drive, one of the things you constantly have to do is lubricate the chain. You can buy self lubricators though. So you keep a little bottle that's got basically a brush that runs up against your chain and drips onto it. So that oil slings all over everything. It's hard to keep the bike clean. So normally they'll have a chain guard on it, and inside the chain is guarded, messed up.
Jan,
And also, you have to have pretty good alignment between your driver and your driven. If one of them's off, then the chain, it'll wear on one side, it'll wear the teeth on your sprocket, which is pretty bad. Chain drive we use a lot. We use it a lot because it's just a lot more flexible in gear, right? I understand that. Are we okay? But these are pretty jerky, so that means they don't like things that oscillates a lot. Plus, if you got too much slack in your chain, I don't know if you've ever seen these things can start oscillating and cause you all types of problems. So we have tensioners like he's talking about. These idler wheels, it's tensioners. So, like in a 10 speed or 15 speed, if you got a bicycle, especially changing gears, the chains have got to be so many different lengths that it's got that tensioner back there or that idler wheel. It's got several functions. It does what? It allows us to change the gear ratio or the sprocket ratio is probably more correct to get different speeds. So chain drive. So the advantage: transmit high torque, right? Small package, relatively low installation cost. Readily available in stock. Like he said, these chains are out there. You can get them for different pitches, but all you got to do is make sure the pitch of your sprocket matches the pitch of the chain. 95% efficient, installed correctly. 50,000 design life is probably maintained. Versatility. It can create chains of what? Any length. Disadvantage, you got to do what? Keep them lubricated. If I ever rode a bicycle, don't lubricate the chain. What happens? Nut stuff on you. Alignment, keeping good tension, and then I don't know what the driving on. Are we okay? Any questions on the chain? Chain drive. Do we keep these things closed up? They're very, very dangerous. You see people coming in and they're trying to line us up and grab the chain over it. Try to move it with the chain. Move what they're at or something will jerk and then they get their fingers in between the chain and the sprocket. Yeah. That's always fun. You're like crying. Huh? Oh yeah, yeah. So you can tell people that ride these open chain bikes, one side of their pants will be tore all to pieces. And they put multiple chains, if you ever watch what the American Chopper was that all the time. The American Chopper with the two dad and they put the chain drives on there, they'll put like 4 chains on there they don't cover them up and tear them up. Belts. So what advantage does belts have? Well, they can handle equipment or wobble, right? You'll understand. They can handle. They automatically have a built-in for startups and stuff like that because they have a little bit stretching capabilities too. What's another advantage they have with the chain? Yeah, they don't have to be as precise. Alignments don't have to be as precise, even though they have to be pretty good. But they're easy to align. Normally, you can use a flat edge and just align what we call the pulleys, right? You understand? Really, just the pulleys. We do have idler pulleys on these too. So we have what we call drive and driven, right? So the driver is the one that connects. These are the ones that point back toward the source of your power, and the driven is going to be the ones that's on the source of your load, right? Does that make sense? The location. Well, belts have evolved a lot against over the time. So we have what we call flat belts. And then what we have what we call synchronous belts, timing belts. You see the difference of these. These are actually two. Then we have a B belt, which is probably the most predominant belt out there. A lot of B belts. And then we have a notched belt. What advantage does a notched belt have over a B belt? Well, it's got two advantages. It's more flexible. So B belts are more flexible, so we can have smaller, pulleys and stuff on the B belt. Another thing is it runs cooler. Why does it run cooler? It's got all those notches in there circulating wind, right? Then we have a multiple ply belt. Which is basically multiple B belts that have the same back. Are we okay? I think this one is. So I need to get this one. Make sure I get this one up there. That's the one I wanted to show y'all, but this guy gets into a lot more detail. So. Where'd it go? So these are the categories. The one we have over there, so what happens on your pulleys will be toothed, right? You understand? So your pulleys will have teeth in them. And the advantage of these, of course, is that they do a real good torque job, but there's no slip. Most of your belts are slip, and this is one of the things that it iterated, that chain drive, if something happens and the system stalls, something's going to happen. Something's going to burn up or the chain's going to break. On the belt drive system, though, if something stalls, then the belt just usually slips. So if you try to get more torque out of it, then the belt's designed to handle, the belt just starts slipping, right? You understand that? Which is another big advantage. Of course, one of the biggest advantages of belt drive and chain drive is what? Yeah, belts are cheap. Huh? Well, we don't have to lubricate them. They don't have to be lubricated. In fact, we don't want them to lubricate, right? Yeah, because then they really start slipping. Yeah, you got in your car because they start getting wore out. But they're getting away from V belts in cars now. They're going to what they call a serpentine belt, which is a tooth belt, because of that reason. Then we have the major belt called the what? Conveyor. So what is a conveyor belt? Well, it's basically a flat belt, right? You understand? That's designed to slide. So it has very low friction on it, right? You understand that? And then we just, whatever we want to move, we put on the belt and it slides with the belt. A continuous moving band of fabric, rubber, or metal. So we do have some conveyor belts. They call them a lot of people call them roller belts. Have you ever seen roller belts? Out of U.S. Steel, they have a bunch of conveyor belts that are basically steel. And the rollers actually have motors on them and they move or still do the same thing.
That was something like something like food company use stainless steel.
Yeah, they used a lot of stainless steel. If you went into like these baggage sorting places at airport, they usually use rubber. They use a combination of both. So, continuous moving band of fabric, rubber, or metal used for transporting objects or material from one place to another. The longest belt in the Western Sahara is 98 kilometers or 61 miles long. Consists of a belt of rollers, drums that served as the platform, right? Free to rotate around a series of rollers, we call them drums. Normally, for each belt, we have a drive belt, and then all the other drums will be what we call idlers, right? Y'all understand that? So we'll run either the drive forward will be run through belts, or it might be run direct drive, or it might be running from a gearbox. Then material to be moved is placed on the belt as the roller moves. So this is an example of a conveyor belt. This is a picture. I don't know where this guy is. Y'all see that conveyor belt? They got one. We've got one. US Steel's got one. If you go out to Concord, you go under that thing. That thing goes all the way from Northport, out on the river, all the way over, not Northport, Burningport, where US Steel has their barges and stuff coming in. And it goes all the way to Fairfield.
They have sections of it transfers, right?
Yeah, but it's real neat. That belt, I don't know how long it is, but that's a pretty good length of a belt there too.
Yeah, but they still wait to hang down.
Keep that tension. Yeah, keep the tension on it. What determines the speed of the belt? The circumference of the roller, which is the length of power. Every time the roller spins one revolution, the belt will move the distance of the roller. The distance of the circumference of the roller, the outside of the roller. The unit does not matter. We say it moves each unit per centimeters or meters. Multiply the RPM of the prime mover by the circumference of the roller. This will give you the speed. That's pretty good. Pretty easy, right? Yep. You okay? I mean, that's about it on conveyor belts. When you're running conveyor belts all over the conveyor belt. Like I said, a conveyor belt does not necessarily have to be a fabric or rubber belt. So anything that moves these material from one place to the other, it could be rollers, it could be belts, it could be chains. I've seen conveyor belts on chains. It's very popular on printed circuit boards, where they'll put the printed circuit boards on chains, and then they move it down through while they're doing the flow solvering and that kind of stuff that's through. And those use their chain conveyor belts. We have two conveyor belts. Well, actually, we got multiple conveyor belts. Yeah, that's conveyor belt. When they get the different handlers, they bring those out of the plane, and then they just throw them on a conveyor belt, and then it comes to sit dropping in. And then even when they sort them and stuff like that coming out of those, which is pretty interesting. I think Denver has one of the longest belt systems inside their sorting, where they sort all the luggage and stuff, all the packages and stuff like that. A lot of your grocery store chains, the big warehouses have really intensive belt systems. If you ever look at like Amazon or some places like that does a lot of moving different material around, it's basically belt systems that move that around and decide. So you have people that pull the orders, and then they'll put a barcode on that thing, and then they'll just throw it on a conveyor belt, and then it goes through all those things and automatically sorts them and puts them on different belts to finally get those things to different airplanes and all those other kinds of stuff. And so we use conveyor belts all over the place to move material from point A to point B. Codeworks was out in Fairfield. They had a belt from the Codeworks that ran coke over to number 8 blast furnace. And so they ran it as soon as they made it. They loaded it on that belt and shipped it over there. It was a lot cheaper to do that than try to run it, but try to handle it with rail. So they have a lot of different companies. I use belts, conveyor belts all over. What's nice about it, material can move or slide around. It doesn't cause much problems. So you'll see in these sorting places, well, they'll have these arms, they'll have one belt going one direction, another one, they'll have a little sorting arm that just comes up there and swings around and just, routes packages either on belt A or belt B, and it just slides them across the belt. Yeah, and of course we've got that over here on the Amtro line where it has a pusher that comes out and pushes the metal over to one side of the conveyor and puts the acrylic on the other, which is a pretty neat system. Of course, our conveyor belts are very, very small, but there's very few industries that you're going to get into where you're not going to run into conveyor belts or manufacturing, even automobiles. It's hard to see, but a lot of those automobiles are moving on chain conveyor. So they'll put those on dollies or something. The dollies are clamped onto a chain, and the chain moves. And those automobiles, move through that. So if you went to a Mercedes down there, you're going to see tons of conveyor belts. Maybe not these rubber ones that you run into, but grocery stores, you see conveyor belts at, grocery stores where you unload your buggy, you put it on a conveyor belt. It's very easy for them to convey all that material over there. Well, that's what they're trying to get the equipment in all their lines basically the same. So it'd be easier for them to maintain. It'll be easier for them to come up with preventive maintenance schedules. It'll be easier all around. If all the lines, no matter where they're at, use the same robots, if they use the same, the same PLCs, so the lines themselves will be easier to maintain. So that's why originally when they came in here, they used stuff that was predominant in the United States because that way they wouldn't have to go back and retrain so many people. So they used Fanuc robots, which was the predominant robot here, probably still is. But ABB is probably giving them a run for their money. Yeah. And then Allen Bradley PLCs were the predominant PLCs. But, so now that Mercedes is moving over to Siemens, a lot of their tier one manufacturers are moving over. So it would be a hit and miss in our local area of which one basically is the more predominant. I imagine it would be pretty close now. But Allen Bradleys are still the predominant PLC in the United States because they're built and they're here.
Yeah.
Yeah, just transmitting the same information from the same. Of course, the information they provide and Allen Bradley provides and the Siemens provide probably is not going to be.
No, I'm not talking about that. I'm talking